Okay students, now let me tell you about complex numbers. Model complex number z is equal to a plus ib, or we can express as x plus iy, or we can express m plus in. So whatever it may be, the model should be like this: a plus ib, where a is called real part of a complex number and denoted as a is equal to rez. Rez means real part of complex number z. A is real part of complex number z, and B is called here, B is called the imaginary part of a complex number, denoted as B is equal to imz. Imz means, im means imaginary, imaginary part of complex number z. So A is real part of complex number z, B is imaginary part of complex number z. For example, z is equal to 2 plus iy or 2 plus 5y. We can write like this also. Z is equal to 2 plus i5. 2 is real part and 5 is imaginary part. So real numbers can be expressed as complex numbers. This is very important. Real numbers can be expressed as complex numbers. Here are some examples. See, real numbers are collected this side and their complex numbers are wrote. So 1 is a real number. Complex form, its complex form is 1 plus 0i. 1 plus 0i means there is no imaginary part, only real part is there. See, minus 2 can be expressed as minus 2 plus 0i or i0. I0. See, minus 2 plus I0 or 0i is the complex form of this real number, minus 2. And 3 by 2 is a real number. So we can express this as complex number. 3 by 2 plus 0i. 0 also can be expressed as complex number. How it is? 0 plus 0i. Means real part is also 0. Imaginary part is also 0. So root 2 can be expressed as complex number, root 2 plus 0i. And minus 4 by 5 can be expressed as minus 4 by 5 plus 0i. Means imaginary part is 0 and real part is minus 4 by 5. So one more example, 0.31. How can we express this as a complex number? So its complex form is 0 plus 3i, sorry, not plus, 0.31, it is 0.31, 0.31 plus I0, 0.31 plus I0 is complex form of this real number. Okay, so now next concept is equality of two complex numbers. Means when we have to call two complex numbers are equal. When two complex numbers are equal. So two complex numbers z1 a plus ib and z2 c plus id. See, this is one complex number which is denoted as z1, that is a plus ib, and z2 is another complex number, that is c plus id, are equal. That is z1 is equal to z2 if and only if a is equal to c and b is equal to d. Means the first complex numbers real part must be equal to the real part of the second complex number, and imaginary part of the first complex number must be equal to imaginary part of second complex number. Then only these two complex numbers are equal. So what is the meaning of equality of two complex numbers? Two complex numbers are equal only when their real parts and imaginary parts both are equal. So on the basis of this one, we will do a small example here. See here, if one complex number 4x plus I into bracket 3x minus y is equal to another complex number 3 plus I minus 6. See, this complex number is equal to this complex number, because actually you just observe this one. This is a plus ib form. A plus I b. 3x minus y is b. 4x is a. And this complex number is equal to another complex number, that is a plus ib. Means 3 is a and minus 6 is b. So when these two complex numbers are equal, where x and y are real numbers, then find the values of x and y. So now already we studied the concept, that is when two complex numbers are equal. So when their real parts and imaginary parts are equal. So here real part is 4x. So that must be equal to the real part, that is 3 of second complex number, because it is told that. So these are equal. So then when two complex numbers are equal, then their corresponding real parts are equal. So this implies that x is equal to 3 by 4. The value of x is equal to 3 by 4. And imaginary part, that is 3x minus y, is equal to minus 6. Here minus 6 is imaginary part of second complex number, and 3x minus y is imaginary part of first complex number. So these two complex numbers are equal, therefore their imaginary parts are equal here. So when we solve this one, see, 3x minus y is equal to minus 6 means here x value already we got, that is 3 into 3 by 4. X value is 3 by 4, minus y is equal to minus 6. Now 3 3s are 9, 9 by 4 it is, 9 by 4 minus y is equal to minus 6. Now minus y I transfer this side, that is plus y, and minus 6 I will transfer this side, that is plus 6. You just understand this one. Minus y I transfer that side, plus y becomes plus y, and minus 6 I transfer left hand side, therefore plus 6. So get the LCM. 4 1s are, that is 9 1s are 9, plus 1 4s are, means 6 4s are 24, that is equal to y. Therefore y is equal to 24 plus 9 is 33. 33 divided by 4. So y value is 33 by 4. So this problem is solved on the basis of, on the concept of equality of two complex numbers. Clear?